In this video, we're going to evaluate the integral of the square root of 2 over the square root of 2x squared plus 18. And of course, the first thing you have to decide is what approach, what method are you going to use to evaluate the integral. You can rule out the partial fractions. Use substitution is probably out. And this one here is actually a trig substitution. Might not look like that for now, but let's look at some of the formulas that you have. If you have an integral of this form, either in the numerator or the denominator, the first one, you use the substitution u equal to a sine of theta. I have a u here because sometimes these will involve a combination of trig and a u substitution. This could be just a plain old x here, and you would use this setup. U equal to a sine theta, and then the square root of a squared minus u squared actually reduces to a cosine theta. Using these identities here at the bottom, Pythagorean identities. One form of these, cosine squared theta plus sine squared theta equals to 1. 1 plus tangent squared theta equal to secant squared theta. The second one, you got the square root of a squared plus u squared, and then you have the substitution u equal a tangent theta, and then the setup on the right is actually using a form of these identities here. For the second one is actually, and that's the one we're going to use, is the second one here. 1 plus tangent squared theta is equal to secant squared theta. And then you have the third one. But in our case, we're going to be using this middle setup here. But first we want to simplify the integrand here. Always simplify the integrand if you can. You get a different look. So notice in the denominator I can factor out a 2 here, and this will give me x squared plus 9. So I can actually write the denominator as the square root of 2. The factor here, so that'll be the square root of 2 times the square root of x squared plus 9. And then of course this and this I gotta cancel, and I'm just gonna get a 1 or a dx over the square root of x squared plus 9. So this is going to give me then the integral 1 dx, so I'll just write dx here, over the square root of x squared plus 9. And this will be the second entry in that table that I looked at. It will be x equal to a tangent theta, so in this case the u is x, and then the 9 is the same thing as 3 squared. So in that formula, a would be 3. X equal to 3 tangent theta. You can also think of this as tangent of theta is equal to x over 3. Because we will need a triangle, reference triangle, right triangle to complete the solution of this. So we have these substitutions. And then dx, derivative of the right side, it would be constant is 3, and then derivative of tangent is secant squared theta d theta. And then in the denominator, what we're going to do now is transform this integral into one involving the variable theta. So using the substitution, I'm going to take the, let's do it this way, dx, and I can replace that by what I have here. So this is going to be 3 secant squared theta d theta. And then the square root of x squared plus 9. Get a substitution for that using the fact that we know that x is equal to 3 tangent theta. Put tangent theta here, or 3 tangent theta here for the x. You're going to square that, so that'll give me a 9. So replacing the x by 3 tangent theta, and then squared it, I get 9 tangent squared theta plus 9. And then I factor out a 9 here, and that leaves me with a tangent squared theta plus 1. And the square root of 9 is 3. And again, this is one of the identities I pointed out below the table. Tangent squared theta plus 1 is the same thing as secant squared theta, but then we have the square root here. So that gives me secant theta. So for this here, in the denominator, I can replace it by 3 secant theta. Now we have the integral in terms of theta. So we can simplify this now. Always simplify when you can. 3 and 3 here cancel. I get secant squared and secant theta divided out. I get the integral of secant theta d theta. And then there's a formula for the integral of secant theta that you should memorize. I actually derived it in another video, but it turns out to be the integral of this is ln of absolute value of secant theta plus tangent theta, absolute value of that. There's your constant of integration. And that's the integral, except it's in the variable theta. We want it back with the original variable x. So what we need to do here is draw the triangle here. Right reference triangle here. Label this as theta. And remember, tangent of theta is x over 3. And by definition, tangent of an angle is the opposite for the right triangle. Opposite, so that's x over the adjacent side. And then we complete the right triangle here. This will be x squared plus 9. Now with that information, we can transform the answer in terms of x. So let me continue this over here. So this is going up here now. So it's ln of the absolute value of secant of theta. So let's look at the right triangle. Secant is the hypotenuse over the adjacent. So it's this square root of x squared plus 9 over 3. So this will be the square root x squared plus 9 over 3. And then it's plus tangent of theta. Of course we know that's x over 3. And then it's the plus the constant of integration. And then we can simplify this a little bit. This is equal to then the natural log. We have the same denominator, so we could do this. This will be 3 in the denominator. Then on top we'd have the square root x squared plus 9 plus x plus the constant of integration. Now depending on what they tell you, you could give this as your answer. But you might see this in this form. Notice that we have the square root of, I've got an x squared here and an x here. So this quantity is positive, and it doesn't matter if x is negative because it's going to be larger than the x here. So I could remove the absolute values there. And this answer then would be the square root of x squared plus 9 plus x plus the constant of integration. You might see this answer if you're working this from a textbook with has the answers in the back. You might see this as your given answer, or you might see this answer here. They're both acceptable. Natural log, square root of x squared plus 9 plus x plus the constant of integration. What happens is they'll do this. They'll rewrite this. You have the log of a fraction, so you actually could rewrite this part right here as the natural log of the square root of x squared plus 9 plus x minus the natural log of 3. So this part right here, the natural log of the, and of course I removed the absolute values because this was positive, log of a fraction, so it's the log of what I have in the numerator minus the log of the denominator. But see, this is just the constant. So this constant could be absorbed in the constant of integration here. That's why you can give either this answer here or that answer there. Thanks for watching. We'll see you next time.